Now we're going to look at traps and trap seal loss. So at the end of this part of the session, I want you all to be able to explain the purpose of fitting traps, recognise at least 4 different types of trap, and describe at least 5 different types of trap seal loss, including how it could be prevented. So what is the purpose of traps? Why do we fit them? Well, we fit them to stop smells getting out into the property. And they do this by using a plug of water as a seal. There is also a waterless trap, which is known as a valve, actually, a self-sealing valve, which we're going to look at a bit later on. And the depth of seal is from this point here up to the point at which it would overflow. So if the water level drops below this point, the trap would no longer be considered as having a seal, and the smells could get out from the sewer. So the name of the trap is often to do with a letter that they look like or an object they might resemble. So let's have a guess. Which ones would be known as an S trap, which one would be known as a P trap, and which one would be known as a bottle trap from the examples on the right here? Well, you have a look at this one and think, well, it looks a little bit like a bottle. So this is a bottle trap. This is actually an anti-vacuum bottle trap, you can see, because of this little connection here. But yeah, a bottle trap. And we've got a P trap here, which if you turn it on its side looks a bit like a P, and an S trap here, which if you turn it on its side again looks a bit like an S. Okay. Worth noting, we don't use bottle traps on kitchen sinks because they are prone to blockage. So traps can also be named after the appliance they serve. We've got a bath trap here, a shower trap here, a washing machine trap. Some people might also call that as an extended P trap, but yeah, I would call it a washing machine trap. Though you can also, probably more often these days, connect the washing machine into the kitchen sink trap, like through a connection like you can see just here. Some other traps we need to be aware of. This is some people call it a straight through trap, but it's essentially acts like an S trap as well. Might be fitted under pedestal wash basins. It's compact, it's easily hidden. Okay. But it can be subject to self-siphonage. The running trap is this example here, and this is used to trap the pipe downstream if there's not enough space under the appliance. You could also use a running trap to trap multiple appliances, essentially. So anti-siphon and anti-vacuum traps. All of the traps that we've looked at are potentially at risk of losing their trap seal, particularly if they're fitted on the end of a long run or a steep pipe run. They should all have anti-siphon or anti-vacuum alternatives that you can see here, and you can see just this little bit sticking up here. That essentially acts as an air admittance valve, and it allows air in to break the siphonic effect. So if any appliance was subject to siphonic action, then you'd fit an anti-vacuum or anti-siphon alternative. Okay. So yeah, worth noting, almost all of the appliances connected to a soil stack would have a depth of seal of 75 mil, with the exception of a WC, a bath, and a shower tray. All of these would have a depth of seal of 50 mil as a minimum. The reason for the WC is because it's got a really big discharge pipe. It's not likely to discharge at full bore, which is when you're most at risk of siphonage. But with baths and shower trays, they will actually discharge quite a lot of water through them in a relatively small pipe, and the pipe's 40 mil. But they're considered to be flat-bottomed appliances. So therefore, sort of, even if the trap seal is pulled through due to siphonage, there'll be a sort of trickle of water that will recharge the trap seal after it's been discharged. So discharging to a gully, I think we mentioned this before actually. So some appliances are allowed to discharge to a gully. As we've said previously, they need to discharge below the gully grid but above the water seal. But if they do discharge to a gully, the depth of seal is allowed to be a bit different as well. That's because the gully is essentially going to be trapped itself. So there's not a massive likelihood of smells kind of coming back up through the pipework, which actually means that dishwashers, washing machines, baths and showers, if they do discharge into a gully, can have a depth of seal reduced to 38mm, only 38mm. Okay, self-sealing valves. So this is our waterless traps that we sort of talked about previously. It's not subject to trap seal loss because it doesn't have a trap seal. It's got a membrane inside it, which sort of will be squashed together, closed when not in use, and then as the water flows into it, flows through it, it sort of pushes the membrane open and allows it to push through. So all of the faults shown could be remedied by using a self-sealing valve. So if the pipe's too steep, if the pipe's too long, if you've got two pipes connected into one run, which causes a risk of induced siphonage, all of these things could potentially be remedied by installing a self-sealing valve. But you must make sure, obviously, that you hit at least the minimum fall when you install your pipework, even if it does have a self-sealing valve fitted, because it helps prevent blockages. It helps ensure something called self-cleansing velocity, so any solids in the water are carried away with the water. So trap seal loss. So trap seals can be lost in lots of different ways. Generally speaking, it's going to be one of these following 8: either evaporation, leakage, momentum, capillary action, compression, self-siphonage, induced siphonage, or waving out. And we're going to look at what each of these actually mean as we go through the next few slides. You can see them all here. We've got induced siphonage here, where you have one appliance discharging, which is pulling the trap seal from a different appliance. Capillary action here, where you have strands of hair or other material, which is allowing water to be drawn up and over the rim of the trap through capillary action. Self-siphonage, where you have an appliance discharging water, and that creates negative pressure behind it, which causes the trap seal of that individual appliance to be pulled. Compression, near the base of the stack, where you have the air compressed and pushed out through the trap seal. Or waving out, is like we can see here, where the wind blows over the top of the pipe and causes movement, which can cause the traps, the water in the traps, to start lapping from side to side, which can cause them to sort of wave out over the edge of the trap. So firstly, evaporation. Literally, it is what it says in the tin. If the trap's in a hot area and it doesn't have much water flowing into it very regularly, the water will evaporate and potentially leave sewer gases to be discharged out into the house. You can prevent that by fitting a self-sealing valve, or just by pouring some water back into the trap. Leakage, again, pretty obvious in it. Just replace the trap, fix the trap, do whatever you need to do to stop the leakage, and then put water back into the trap. Momentum, this is if you put, probably most at risk in a toilet, for example. If you chuck a bucket of water in the toilet, it can sort of take the sort of trap seal with it, but it's easily remedied. You just put some water in it to recharge the trap. Capillary action, like we've talked about, could be like if you have a rag or some string which is caught over or some hair even, which is caught over the edge of the trap, and it can pull some of the water up through it by capillary action, and that can sort of drip away off into the drain. So you can fix that by clearing out the trap normally. Compression happens at the base of the stack. And that's if you have a build-up of water at the base of the stack and a lot more water discharging down on top of it. That can cause a build-up of positive pressure, which can then force the sewer gases out through the trap and into the house. It's remedied by increasing the distance between the base of the stack and the bottom connection, base connection. Okay. Self-siphonage. Self-siphonage is when a trap seal causes itself to lose its own trap seal. If you have, for example, a plug of water, if discharged at full bore, creates a plug of water which pushes air in front of it. That leaves negative pressure behind it, which can then cause the trap seal to be pulled through. You can prevent that by using an anti-vacuum trap or an air admittance valve on the run. And the same is true of induced siphonage. The only difference between self-siphonage and induced siphonage is when you let one appliance go. You've got two or more appliances connected on the same run. You let one appliance go, and the trap seal is pulled from a separate appliance, a different appliance. And again, you can prevent it in the same way. You fit an air admittance valve or a self or a anti-siphon trap. Okay, waving out, again, like we talked about, it's caused by wind blowing over the end of the stack, can cause the trap seal to be pulled from the trap, but just water starts to lap from side to side. You can prevent that by fitting a vent cowl at the top of the stack. Now it is time for your task.